Hello and welcome to the channel. Here is another arithmetic problem from the same source as the previous one, the link to which you will find in the description below the video. As opposed to the previous problem, this one is clearly specified and leaves no questions. So a car and a motorcycle move in same direction, both at constant speed. However, the motorcycle is slower. A pedestrian also moves at a constant speed, but in the opposite direction, towards the car and the motorcycle. Initially, the car and motorcycle are at the same spot, 30 kilometers away from the pedestrian. Then the car meets the pedestrian while the motorcycle is 5 kilometers behind. Next, the motorcycle meets the pedestrian while the car is somewhere ahead of them. The question is, how far ahead is the car? The solution I am going to present here is based on the relative motion. We know that when moving toward each other, the relative velocity is the sum of two velocities, whereas in case of same direction, the velocities are subtracted. However, my solution doesn't add or subtract velocities, it uses a different idea. Of course, you are welcome to suggest your own solution, so please pause the video and try to find it. Let's agree that the motion is always regarded relative to the pedestrian. RTP for short, what is called pedestrian's reference frame in physics. In such a frame, the pedestrian never moves, while the other actors move towards the pedestrian and then away from it. So we have a road and the pedestrian standing somewhere beside the roadway, while on the roadway there are a car and a motorcycle. Initially, both the car and the motorcycle are located 30 kilometers away from the pedestrian. Then the pedestrian is assumed to stay, while the car and the motorcycle are moving toward it. Eventually, the car meets the pedestrian. Call it the first meet. At this moment, the car traveled 30 kilometers relative to the pedestrian. In fact, 30 kilometers is the total distance traveled by the car and the pedestrian. However, if you consider the motion relative to the pedestrian, who is assumed to stay still, all that distance must be attributed to the car. The motorcycle is 5 kilometers behind the car. Therefore, the motorcycle's traveled distance relative to the pedestrian is 25 kilometers. This means that relative to the pedestrian, the ratio of car's velocity to the motorcycle's velocity is 30/25, which is reduced by 5 to 6/5. They continue moving till the second meet, when the motorcycle meets the pedestrian. Now, the distance traveled by the motorcycle from the first meet relative to the pedestrian is 5 kilometers. And we know that the car moves 6/5 times faster than the motorcycle. So in order to find the distance traveled by the car, we multiply 5 kilometers by 6/5 and get 6 kilometers. Since at the first meet the car was near the pedestrian, 6 kilometers is actually the distance between the car and the pedestrian at the second meet. It is also the distance between the car and the motorcycle at the second meet, the one we needed to find. So the answer is ready, and this is the end.